Okay, so on this one, what we're going to do is we are going to be discussing um, solving a system and what a system really is. Um, so what a system is a system of linear equations is basically two lines being graphed at the same time. And a solution to a system is where those two lines cross. So that's how you figure it out. A solution to the system is where those two lines cross. So when you're looking at this, what you can do is, what's the solution of the system? Use the graph. So you got y equals uh, x plus 2 and y equals 3x. Well, what you can do is you could actually graph those. So that y equals x plus 2, I'm going to go to positive 2, so 1, 2, and then I'm going to put a dot. So if I do that, so 0, 2, put a dot. Okay, and then up 1 over 1, put a dot, up 1 over 1, put a dot, up 1 over 1, put a dot, and then I draw my line. And my second line is y-intercept is 0, negative 2, so down to 2, 1, 2, put a dot. And I'm going to go up 3, 1, 2, 3, over 1, up 3, 1, 2, 3, over 1, and I'm going to draw my line. Now, where do these guys meet? It looks like they meet right about here. It looks like it's at 1, 2, comma, 1, 2, 3, 4. Looks like they're at 2, comma, 4. Okay, does that make sense? Hey, you haven't got it. Why don't you pause the video and do the guide? I'll see you back here in just a minute. So here's one. It says, biologists, scientists study the weights of two alligators over a period of 12 months. The initial weight and growth of each alligator is shown below. After how many months did the alligator weigh the same amount? So first alligator was 4 pounds, and his rate of growth was 1.5 pounds per month. And the other alligator was initially 6 pounds, and the rate of growth was 1 pound per month. So what I'm going to do is I'm going to say this. I'm going to write, all right, so y equals, the initial weight was 4 plus 1.5x. And the other guy is y equals 6 plus 1x. Now when they say, where are they the same? When they say, where are they the same, how would I figure that out? There's a couple ways you can do that. So what I could do here is I could graph these guys. So if I draw an x and y-axis, so I go up to 4, 1, 2, 3, 4, and put a dot. And 1 and 0.5, I guess I can go up 3, 1, 2, 3, and over 2, 1, 2, and put a dot. I do this. This guy's 6. 1, 2, 3, 4, 5, 6, put a dot. Up 1, over 1, put a dot. And I go over here. This location is where they're going to be the same weight. Now, an easy way to do that is to do a very accurate graph. So let me show you how we could do that with a very accurate graph. What I went to is this super awesome website called Desmos. And if you check this out, I'm going to go ahead and put in that first equation. The first equation was y equals, and I guess it was 4 plus 1.5x. And then my other one was y equals 6 plus x. And so when I do that, I can zoom in, I'm going to zoom out, and I can look right here, and I can probably find out where they meet. Looks like 4 comma 10 is where they meet. That 4 comma 10 means that it's 4 weeks or months or whatever, and it's like 10 pounds would be the size of the gator. Pretty cool, huh? You have a got it. Why don't you pause the video and do the got it, and I'll see you here in a minute. All right, so these ones say, what is the solution of each system? Use the graph. So I provided you with some graphs, and let's go ahead and go through it. The first problem I have with A is that it's not written in slope-intercept form. So what I'm going to do with this, guys, I'm going to go ahead and I'm going to add x to both sides. So I have 2y equals x plus 2. Then I'm going to divide both sides by 2, divide both sides by 2. So I have a new one. I have y equals 1/2 x plus 1. So these are my two systems. So let's graph it. First one, go to 1, put a dot, and then go up 1 over 2, 1, 2, and put another dot. Up 1 over 2, put another dot. And then I do that again. Oh look, I go to 1, up 1 over 2, up 1 over 2. These guys are the exact same line. So how many times do they cross? They cross a lot. This is infinite solution. All right, this is an infinite solution. And when you have infinite solutions, it means you have what's called infinite solutions is called dependent system. Okay, a dependent system. So you want to be mindful of that. All right. And so they have infinite many solutions, and it's a dependent system. Let's look at the other one. 2x plus 2 and 2x minus 1. If I graph these guys, I'll go up to 0, 2, 1, 2, put a dot, and then I go up 2, 1, 2 over 1. Here's this line. And then my other one, if I go to negative 1 and put a dot, I go up 2, 1, 2 over 1. I go like this. Notice that these guys, how many times do they cross? They don't. They're parallel. They're parallel, which means there is no solution there. There is absolutely no solution. So what we call this one, we call this an inconsistent system, and they're parallel. So be mindful of that. You have a guide, but before you go to the guide, I want to point out the different types of systems. You have one solution, which is where they cross. You have infinite solutions, which they're dependent systems, which means that the line, you get one line and two equations, or you get lines that never cross, which are parallel. So if that happens, if they're parallel, they have no solutions. Okay. So in your notes here, you have a couple things. If you know what a system of linear equations is, check it off. If not, write out what the definition is, look it up, or figure it out. A system of linear equations is like two lines. All right. Solution. The solution means is where it crosses. So if you know where they cross, that's good. Consistent means you have at least one solution. Independent means there is independent means that they have exactly one solution. And dependent means there is infinite many solutions. Inconsistent system would be a situation where you have no solutions. So please rate yourself on how you feel about this. 0 being I have no idea what the heck's going on, and 10 being that you are great at this. All right? Hopefully this makes sense. I look forward to seeing you in class real soon, and may the force be with you.